Plus, you can't see my face when I'm teaching. So, is that good? Okay, all right. Okay, so weird. I feel like zoomed up here a little bit. All right, got something weird to show you here today, and I'm honest about some things in math are a little bit silly sometimes. Are we listening over there? Make me move this podium back over there. All right. And this is going to be one of them. This is a strange, what I call a semantic, a strange idea that it's picky. Tomorrow I'm going to add something to the directions as I thought about what I want to do tomorrow compared to today, that we won't have to worry about what I'm going to show you right now. But right now you do. And it comes down to this. Okay, first of all, give you a couple easy questions. What's the square root of 2 squared, class? 3, 2, 1, go. 2. But it really comes down to this. Now, I know we were liberally going about, what can I do first? I wanted you to square root first, then square, because we were dealing with positive numbers. You square root on that no calculator thing to get the number down, then you put the power on there to build it back up. And that's the best way to do a no calculator question. But this one, really, the order of operations, what do you have to do first? Square root or square, according to how this is written? 3, 2, 1, go. Square. What's a negative squared? 3, 2, 1, go. And then, so what's this answer ultimately? 2. It's positive. So I know that's where this gets a little fuzzy. You kind of have to do that. This has to be the case how you do this. So here's what's going to happen today. This is why I built this up. I bet you everyone can answer this. What's the square root of an unknown squared or x squared? 3, 2, 1, go. What's the answer? It is x. But here lies the problem. What if x was negative? And I plugged in -2 for x. Well, then this would be -2 over here, and it cannot be. It's impossible because of everything I went through up here. So what you have to do is put an absolute value around this. You must ensure that this is going to be a positive. Now, again, I'm just being the informant here. I'm annoyed by this rule. I think I don't know if in the regular math 2 classes they even cover this. They may or may not. I'm not really sure. They have to see when they come in for tutoring. But I actually don't get a math 2 student to come in too often, so it's a bummer. And then it's the same with this. 4th root of x to the 4th. Well, before I do that, let's just look up here. What's the 4th root of 7 to the 4th? What's the answer to that? 3, 2, 1, go. We should know that. These are like opposite operations. So what's your instinct to say for this one? 4th root of x to the 4th is what? 3, 2, 1, go. X. But then herein lies the problem again. If I were to go up here and make this a -7 to the 4th, and then 4th root that, you would still get a +7. So this should also have an absolute value around it. So here's the rule. The rule is and by the way, this index right here is a 2, but you will never see that or need to write it. But what I'm going to write next, this is why I did that. Whenever you have an even index, this is the one big star that you got to remember, and an odd power results. I don't know if my English is great here. Don't care. Or I couldn't. See, you got that wrong. Couldn't care less. Odd power results, you need absolute values. Maybe put that in words there. That's an absolute value. So I want you to understand this. And I think you probably could get this right. What's the square root of x to the 4th? What times itself equals x to the 4th? 3, 2, 1, go. Do you know? X to the what power? Second. Now, why would I not need absolute values around here? If x is negative, what's a negative squared? 3, 2, 1, go. Positive. So it's useless to put absolute values around there. You would get a positive out of this. So put those as like conditions there and do not put absolute values around that x squared. That, again, is this sentence. You have an even index and an odd power results. You must ensure the positivity of that, so you must put an absolute value around that. Now, and then it really is based off of this. What's the cube root of, and I'm going to use this in terms of powers, 2 to the third. 3, 2, 1, go. 2, I lost them. But then what's the cube root of negative 2 cubed? First of all, what's a negative cubed? 3, 2, 1, go. A negative. And what's the cube root of a negative? 3, 2, 1, go. A negative. So when I'm doing the cube root of x to the third, and by the way, that's I can simplify radicals with variables. We're throwing variables into the mix today. So this is why, I'm going over this. Do I need an absolute value around this? Actually, be wrong, because did I get a positive when I evaluated that cube root up to the right? Yes or no? No. So I do get a negative when I cube root a negative. So it'd be wrong to put an absolute value around that. If x is negative, you will get a negative as a result. So I know this is kind of like, whatever, but this is what's happening. What's the fifth root of x to the fifth? 3, 2, 1, go. Oh, where'd you go, fourth hour? What's the fifth root of x to the fifth? 3, 2, 1, go. X. Do I need an absolute value around that? Absolutely not. It'd be wrong to actually put that around it, because fifth root of a negative would be a negative. So if x is negative, you get a negative, and that's what has to happen. So again, it is a pain. I'm not a big fan of that rule, but it exists out there. I doubt on an SAT exam they concern themselves with that, but I don't know. Oh, none of you took that. We used to do practice SATs even for sophomores. Oh, yes, we are going to do that in spring. You guys do take one in spring, but for some reason the juniors. Was it yesterday? Did you? No, it was yesterday. I think I had a sophomore in my last hour take it, actually. Did any of you guys take it? That practice test yesterday? No? I did. I had a girl take it. That's weird. She must have signed up for it. Okay, anyway. I'm mentioning that SAT, I doubt they do that absolute value rule, but maybe I'm wrong. I don't know. Okay, we had this like 2 or 3 times yesterday. What's the fifth root of 32? 3, 2, 1, go. 2. But here's why, if you're struggling, don't ever. I'm going to tell you, you non-work showers, this is going to be your favorite day. I don't want you to write this down, but I do want you to understand it. 32 is 2 times itself 5 times, so I can write it as an exponent. And then I am going to write this out. Instead of writing 15 m's, that's what m to the 15 means. There's 15 m's multiplied together. But what I am going to do is group them up in fives. M to the fifth, m to the fifth, m to the fifth. And they are times. Okay, and then just know, I don't know how else to explain that. That's what the, exponents mean, and this is what we can do. So you already said the fifth root of 32 is 2. And then for every m to the fifth, I get to take 1 m out. Or the fifth root of m to the fifth is m. But there's 3 of those. That equals m to the 15th. So the final answer is 2m to the third. And I'm just going to tell you right now, I don't need any of that. This is the one time where I say, yeah, you should be able to just get the answer on these because they work out nice and evenly. Okay, but I'm going to unscratch that out. Okay, and I forgot what else I wanted to say about that. Oh, and then someone came up with a rule. Can't I just... And then he said something about this in first hour. What do you think he said? Can't I just what with those two numbers? Divide. Because really that just tells you how many m to the fifths there are. M to the 15th, cube root of it, or fifth root of it, sorry. So 15 divided by 5 is 3. So that means there's 3 blocks of m to the fifths. So therefore, m to the third comes out. All right, so yes. And that's why, again, I don't need any of that work if you don't want to show it. Okay, it's okay. I'm just doing this for teaching purposes. Okay, so I don't think I'm going to write. Oh, One more thing. Do I need an absolute value around anything? Yes or no? 3, 2, 1, go. No, it's a fifth root. Move on. It has to be an even index to do that silly square root, or I'm sorry, silly absolute value thing. Can you imagine me writing out 20 X's? I used to do that for my regular algebra. I'm having a flashback from the 90s. I used to literally write, okay, class, here's 20 X's. What you want me to keep going? No. But for every 4 X's, how many come out? Tell me that. 3, 2, 1, go. No. For every 4 X's, how many X's come out? What? One. But then what is the final answer? It definitely is X to the what? Fifth, and then Y to the what? Second. Okay. I could do it with the Y's. I used to do this with the Y's, just looking at the Y's alone. Y. For every 4 Y's, 1 Y comes out. For every 4 Y's, 1 Y comes out. 2 Y's come out, Y squared. Used to call it the jailbreaking method for radicals. This 4 tells me how many Y's I need in order to break one out. All right, but I think we're pretty quick with stuff, and we understand, exponents well enough, I hope. Did you do exponents last year a little bit? I have to cover exponents on Monday because radicals are a form of an exponent. They really are. Showed you that yesterday with the fractional exponent idea. All right, does anyone need an absolute value around it? X, Y, or none? 3, 2, 1, go. Oh, wait, so who needs I got to hear you guys. Fourth hour is crumbling here. 3, 2, 1, go. X, only 2 people are saying something. Dudes, for an even power or an even index and an odd power results, you need to ensure that it's a positive number as an evaluation if I threw in a number for X. Okay, don't need it around Y squared because if Y was negative, you'd square it and get a positive. Okay, so that's really what's behind the rule. All right? You try. Okay, well, I'm doing these verbal things. Let's everyone verbalize. Hey, everyone, what's the cube root of -8? 3, 2, 1, go. -2. Hey, everyone, what's the cube root of a to the third? 3, 2, 1, go. Oh my gosh, what's going on? Do you guys not understand? What's the cube root of a to the third? 3, 2, 1, go. A. What's the cube root of b to the ninth? 3, 2, 1, go. B to the third. You can barely hear him. There's no energy in this fourth hour. Just make him get up and do jumping jacks. Is everyone okay? Do we need absolute values around anything? 3, 2, 1, go. No, it's a cube root. Let's move on. So imagine today everything should work out perfectly. Tomorrow you don't care about this. I'm switching what I did last year or changing the order. Tomorrow, imagine things not working out perfectly. Like the quadratic formula. What's 12? A number. But what's the square root of 12? Okay, think about it. Square root of 12 is what? 3, 2, 1, go. Oh my gosh, fourth hour. What is wrong with you? All right, so everyone stand up. Let's go. Everyone stand. Come on. I'm making everyone stand up. Get up. Get up. Let's go. Come on. Up. I'm going to kick your chair. Get up. All right, let's all walk around the room for a little bit. Let's do this. All right, come on. Get up. Get up. Get up. All right, now everyone look at me. What is the square root of 12? How does it simplify? 3, 2, 1, go. 2 square root of 3. Did you forget everything? Am I teaching the wrong class here? Sit down, everyone. All right, this is ridiculous. All right, you don't know how to get to the square root of 12, 2 root 3, huh? Right? Square root of 12, 2 root 3. Yes. Oh my gosh. Okay, so here we go, everyone. Let's all answer a question. I'm gonna make you get up again. Oh, this is a tough one. You remember this from yesterday? What's the fourth root of 256? 3, 2, 1, go. Oh my gosh, nothing. I'm gonna collapse. Fourth hour has forgotten everything. It's a 4. It's one of the numbers in our list. Now, okay, I get that one, why you didn't answer that one. I don't know why you didn't do this, but I was trying to make a point. Tomorrow, not everything's going to work out perfectly. Today it is. So there is a perfect fourth root for 256. It is 4. All All right, so that was one of our listed, but I think I put a star by that one. I go, this one's probably the hardest of our perfect fourths. All right, but anyway, here we go again. X to the what? What gets broken out? 3, 2, 1, go. 3. It's got to divide. Or fine. If I just look at the x's, this is x to the fourth times x to the fourth times x to the fourth. That is 12 x's multiplied together. For every x to the fourth, 1x gets to come out. That's 3 x's that come out. So let's go faster on this. Y to the what? What comes out? 3, 2, 1, go. 6. Because I could write 6 y to the fourths. That's why the division thing works out very nicely. Okay, here we go again. Let me just put this back up here because if you don't answer this, I'm going to go nuts. Let's all say this together. Even index, odd power results, absolute value. So, who deserves an absolute value? X, Y, 4, or nothing? 3, 2, 1, go. X, fourth hour. Yay. Education is fun. Okay? Right? This is fun. This is great. Okay, and then one more thing. We're going to solve equations. Whatever you do to one side, say it. Do the other. So, two little things. You're going to walk out of here probably with no homework. That happened last hour. So, I'm almost done, believe it or not. We're going to solve more complicated equations next week. This is a simpler side. But whatever we do to one side, do that. What are we going to do first? Divide by 2. There you go. 3, 2, 1. I didn't say it. All right. And then this is a little different when you're solving equations. Whatever you do to one side, do the other. What do I have to do to both sides? Not square root, but fifth root. Good. Someone said square root last hour. No, you have to throw that index in there and say fifth root. Now, listen, this is the one caveat on this one. A little bit different. Fifth root of 32. First of all, what's the fifth root of 32? 3, 2, 1, go. Everyone should say that because we actually had that number 2 or 3 times yesterday. All right, we did have a fifth root of 32 that we asked you. Now, should it be also negative 2? Let me answer that question with another question. What is negative 2 to the fifth power? 3, 2, 1, go. We're not doing it again. Is it positive or negative? 3, 2, 1, go. No, a negative to the fifth power is what? This is awful. Are you guys sabotaging my video? What's a negative to this? What's going on? So negative times a negative times a negative times a negative times a negative is a what? Negative. So does negative 2 also work for this equation? Yes or no? Yes or no? No. Oh my gosh, this is going awfully. My fourth hour is my highest performing class, too. I don't know what's going on. I'm in a Twilight Zone episode. You guys don't even know what that is. You guys know what the Twilight Zone is? Who knows what the Twilight Zone is? I feel like I'm in one right now. I'm in an episode. Okay, you're fumbling majorly. Okay, so no, only a positive 2 could be the answer. I mean, think about it. Input, say it. If I inputted negative 2 in here, I would end up with negative 64. And negative 64 does not equal 64. So only 2 is the answer. Okay, now we got this one, which doesn't work out. I got to change it. Sorry. Good thing I caught that real quick. I want something different. Let's say 54. Got it. No, that doesn't work. Sorry. Shoot, I can't think. 81 times 2, 162. Did that say 162 there? Or was that 128? Okay, yeah, that doesn't work. I told you everything is going to work out nicely today. All right. So, of course, I got to divide by 2, and I did this on purpose. I got x to the fourth equals 81. All right. And then I fourth root. What is the fourth root of 81? 3, 2, 1, go. 3. But now we got a problem. Does negative 3 also work? Yes or no? 3, 2, 1, go. Yes, because a negative to the fourth power actually equals a positive. So this goes back to this basic rule when I said x squared equals 4. What does x equal? Well, plus minus 2 because negative 2 also works. And then how many people forgot to put plus minus in front of square root answers when we rooted both sides to solve a quadratic? It killed me. I had to mark you wrong every single time you didn't do it. All right. But the same rule applies for a fourth root. All right. A negative to the fourth power also equals a positive. If I threw in -3 here, -3 to the fourth power is 81. 81 times 2 is 162. So this one requires a plus minus. So what I've covered here is when you fifth root both sides or odd root both sides, you don't get a plus minus. When you square root, fourth root, sixth root, and so on and so forth, both sides, you do get a plus minus. Does everyone understand fourth hour? Okay. All right. So two more. Let's just go through it, and then let's see if we, can answer questions correctly. Oh no, Mr. Samuels is a jerk. He doesn't let me have a calculator. Then go back to grade school. Put 320 on the inside, 5 on the outside. 6 times 5 is 30. Lexi Samuels can do this in a heartbeat. 4 times 5, she's only in 7th grade. Okay, so a sophomore in high school should be able to handle this. All right, and then what's the cube root of 64? 3, 2, 1, go. 4, only a few people. Okay, here we go. Everyone's got to answer. I'm going to watch if you're answering. Is it plus minus? Yes or no? 3, 2, 1, go. No. Okay, because it's a cube root. Plus, if I plugged in -4, I get -64. -64 times 5 is -320. That's not what I have. The bells are working again. All right, and then divide by 2. It did work last hour, right? Is this 81 again? Didn't I just have this one? Oh, I just made a mistake when I changed that number. Right? So then what's the final answer? If you get this wrong, you're going to make me cry. 3, 2, 1, go. Because you know what? We just had that one. It's right here. We just did it. Okay, I'm done. That was weird today. All right.